Welcome to Taiwan Talks. I'm Betty Chen. As the global leader in semiconductor industry, TSMC stock price has surpassed the 1,000 new Taiwan dollar mark in the second half of this year, and its American Depository Receipt ADR have also broken the $200 mark. With the market capitalization exceeding $1 trillion and reports that TSMC has begun producing chips for Apple at its Phoenix, Arizona factory, can TSMC continue to dominate the market in the future? And how are Samsung, Intel, and China's semiconductor landscape positioned in response? Joining us today are Jonah Cheng, J&J Investment Chief Investment Officer, and Marco Mezger, Neumonda Executive Vice President and Chief Operating Officer. A warm welcome to both of you on the show. According to TrendForce's forecast, the demand for semiconductor driven by AI is expected to lead to a 20% annual growth in the overall foundry market by 2025, with TSMC continuing to stand out and maintain its leading position from this year. The annual revenue growth rate for TSMC is expected to reach 25% next year, while other foundries are also expected to see nearly 12% of growth. So we see that originally when TSMC announced that it would like to expand its presence abroad, there were some people saying, well, they're kind of skeptical, but now people are changing their attitude, saying, well, TSMC will continue to be the leader in a foundry business. How do you see this kind of change in attitude, Jonah?
Okay, in my opinion, I think TSMC is leading in the technology for the process, that's for sure. And basically for AI perspective, basically most of the AI products, they are using the CoWoS packaging, chip-on-wafer-on substrate. And TSMC is definitely the leader for this kind of packaging technology. So currently, compared with other competitors like Intel or Samsung or all the other second-tier guys like UNC, Vanguard, etc., no one have this kind of packaging technology to compete. So if NVIDIA, AMD, or other AI chip company, they want to build their AI chip and they need to buy more, the only choice is TSMC. So right now, no matter for the front-end process, 5 nanometer, 3 nanometer, or N2, or the back-end like a CoWoS-S, CoWoS-L, or into the next generation like SOIC for 3D packaging, or etc. TSMC already ahead for all different kind of this kind of process. So I think in the next foreseeable future, maybe like 3 or 5 years, we still cannot see any strong competitor to have a big threat to TSMC, in my view.
So, Jonah, you said TSMC can still maintain the competitive edge for another 3 to 5 years. Yes. And according to some recent interview, TSMC Chairman C.C. Wei has mentioned that the demand for AI is still very strong. Yes. And also NVIDIA CEO Jensen Huang has received an interview saying that he still sees the market for AI and also for chips there's a huge demand. So how long do you think that this trend will continue, Marco?
That's a good question. That's the million-dollar question, right?
If you have a crystal ball.
No, seriously, I think, I believe at the moment we have this AI frenzy. I mean, everybody wants to get NVIDIA chips. I think we have the one side on the logic, the chips, but we have also on the memory side, the HBMs. Yeah? And so these high bandwidth memories which are used, I think John mentioned it, you need to have like special packaging facilities. TSMC is the clear leader in this area. I also would say it's very challenging to catch up. I think Intel has some solutions with Foveros, where they're doing solutions, but even Intel is using TSMC to produce certain chips on advanced process nodes. Even they have their own fabs, because TSMC has the advantage that they can launch a new technology process node with the largest consumer electronic company in the world, with Apple, which brings you up volume, which brings you up better yield rates, and so you can scale these ramp-ups very easily. So no other company in the world is able to do this right now. So I agree also with John what he mentioned about this.
So of course, it's a good thing, I mean, for Taiwan to hear that TSMC is doing so well. But I just want to know that, is this are people just too optimistic, or do you think that this is a reflection of the reality in the market? Marco?
I mean, it's probably right now the zeitgeist, you can say, right? With ChatGPT, with OpenAI, everything AI in the smartphones. You have Samsung, you have Apple, they build it in, the data centers are built out. But you also have to understand with this investment is also coming other investments, additional investment. Right? You start with the language models, like that's where you need the NVIDIA chips. Then you have the inference, you have other solutions, you have other technologies. And if we look at AI, at the moment, we are just on the top level for really high-performance computing. But AI can also be done with special purpose AI chips. So these chips don't need 3 or 5 nanometer. You can do this even on major process nodes, 20 nanometer, but they are more narrow in the application where they can go in. But if you think about most of the companies in the industrial segment, they cannot afford a $40,000, $50,000 chip, to run AI. So there needs to be a second wave of AI. So when the first wave basically cools down, then there will be the next one coming. So I think AI will thrive the next decade, basically semiconductors. And if you look at some of the latest interviews, also what SEMI has given about the market outlook, they're expecting that from 2030 to 2040, we will double again our world semiconductor revenue. It was from 2020, from $500 billion to $1 trillion 2030, and now they believe another 10 years, it will be doubling. And that's definitely fueled by the AI frenzy. But we should not forget, semiconductor is not only AI. It's a lot of other commodities, and the other commodities at the moment, they are struggling because of the post-COVID. They have still high inventories. And the global economy in general is not so strong. We have a lot of crisis worldwide, and also the general mood is not like that people spending a lot of money. Besides AI. Whoever can join the AI party, they're doing very well at the moment.
So back to you, Jonah. It seems that you're quite optimistic about the development for AI and also the semiconductor industry. And just like what Marco mentioned, now TSMC, well, according to some reports, they're going to produce the chips for Apple in Arizona. So it seems like a big step. What's the significance of this big step?
Actually, I think it's more like it means that finally the American fab can start to go mass production, and they deliver something, and they are not just keep struggle to make the year rate.
Perhaps you can tell us a bit more about the struggle, right?
Yeah, okay. Previously, I think everyone knows that the engineer in US is not as good as in Taiwan, I should say.
We have different working cultures.
Yeah, the different working culture. We are not saying they are not hardworking, but just the culture is different. So in Taiwan, if there's something wrong in fab, your boss will call you, come back very quickly, and everyone will just come back to make everything go smooth. But in US, that will be very difficult to do these kind of things. So the ramp-up schedule for the US process take much longer than expectation. I think previously, TSMC mentioned maybe like last year or 2 years ago, the Arizona fab will start to go mass production, but this has been delayed for at least 1 or 2 years. But basically, I think it's a breakthrough. However, it's still just a small step for TSMC, because right now, if we look at Arizona fab, it's only running at M5 right now, the 5 nanometer process, and also the capacity is very limited, only 20K wafer per month. So if we talk about the Apple demand today, normally in the hot season, Apple will require at least 40, 50K wafer per month for N3 right now. So Arizona fab can only do part of the Apple product, and for very special, only a small portion of that. So it's a good milestone for TSMC. However, it's just a small step. I think the majority of the customer demand will still rely on the Taiwan fab to help them to deliver the product. Yeah.
So talking about the division of labor, because we're talking about the production for mature chips and also the advanced chips. When it comes to the division of labor, we understand that TSMC has already announced that they're going to build a second plant in Kumamoto in Japan. It seems that by the end of the year, they're going to break the ground and they will start production in 2027. Also, TSMC has expanded its presence in Europe. So it seems that they will continue on that trend. When it comes to the division of labor, what's your opinion? Do you think that, TSMC, although I think that the leadership has mentioned that they will keep the most advanced manufacturing processes in Taiwan, do you think that they can continue to keep this trend, or they will change their mind?
Yes, I think under the current visibility, I would say they'll keep the leading node in Taiwan for sure. For the Japanese fab, I think that will focus on 28 nanometer. And even the second phase, I think that will be the same. That's more like a legacy process. And in the Europe, that's also the same situation. The Euro fab will focus on the automotive application. And also that's focused more on 28 nanometer or above. So also the other thing for the US fab, the Euro fab or Japanese fab is their co-investment with the joint investment with the customer. Like in Japan, they have investment with Sony, and in Europe, they co-investment with like Infineon or like Bosch, this kind of customer. So basically, they just build a fab with the customer together. Customer also paying some money, and they also have government subsidy. So the risk for TSMC is not very high. They already secure the customer. They already secure some subsidy, and that's a mature process. So they don't need to invest much money on that. So, but in US, that's a bit different situation. That's a leading edge process, and also the culture is much more different versus Taiwan. So I think for TSMC building the fab in Japan or Europe, that's much easier than in US, and also that's more like the mature node. But like you mentioned, for the leading edge process, I think TSMC will still keep this kind of facility in Taiwan, at least for the next few years. Yeah.
So talking about these kind of different chips, Marco, you talk about the AI frenzy or AI hype. So now AI is the thing. People are all talking about the chips for AI. But you also talk about there are some other, say, purposes or maybe other industries that might have a huge demand for the chips. Could you please tell us a bit more about that?
I think what Jonah mentioned is like if you look what TSMC is doing, right? So they go outside of Taiwan. It was the first time they go out. They had before a smaller fab in China. But now they go to Europe, they go to USA, they go to Japan. So I think Europe is, for me, like a safe bet for them because they have NXP, they have Bosch, they have Infineon. They share a total of 30% of the investment. And of course, they will also help to fill the fab because these companies want to have some production within Europe, like a supply chain there. So it's a win-win situation, really. So I think it's a good model what they are doing there. And it's their customer base. Also in Japan, you have a lot of semiconductor companies who need foundry services, right? You have big companies who utilize these process nodes so that TSMC can also advance there. In Japan, it's very interesting because we also have Rapidus, which is another company which wants to go into advanced lithography. They will be competing also with TSMC on advanced process nodes. They have also like a similar approach that, you know, not only foundry, but also packaging, testing all together. And I think speaking about the Arizona fab, besides the cultural challenges, we have to see in Taiwan, we have around about 14 fabs for TSMC. Only in Taiwan, you can really push out the volume what an Apple needs. So the volume what they can do right now in USA, yes, it's great that you can produce there some chips, but it would never be enough for the global demand for an Apple or for any other company. I think what we see in the US is that some core technology, production technology is on the soil of the USA. And there was recently an announcement that also MCore, which is a big advanced packaging house, will make a $2 billion investment there that they can also package and test in the facility. Because without this, TSMC would ship the ready wafers back to the USA. So mission not accomplished, right? So I think you need to have a packaging and testing facility to do
like the whole ecosystem.
Right,
to
the
support
ecosystem. But as Jonah mentioned, I think the most advanced from CoWoS, I think this is mainly here. There's a new fab, what also TSMC is building here. And this core technology, TSMC mentioned this over and over again, they keep here. So I think most advanced and high volume. I think that's where TSMC in Taiwan will always be of importance, despite the other fabs which are built at the moment worldwide.
So we have talked a lot about TSMC. Now let's zoom out a bit to look at other countries and other companies. So let's talk about Samsung. It seems that Samsung is facing some difficulties when it comes to the 2-nanometer production. They're withdrawing some personnel from their overseas plant, and maybe the production delivery time will be delayed to 2026. So given the fact that Samsung has received the subsidies from the US government under the CHIPS Act, how do you think that this setback will impact the development of Samsung? Maybe start with Jonah.
Okay, in our view, I think right now the problem for Samsung is they don't have a very strong customer to support them developing the leading edge process. So basically, like Marco just mentioned, for TSMC, they have a very strong customer base. So they have previously they had Huawei, now they have Apple, and also NVIDIA, AMD. All these kind of customer will help in TSMC to drive the yield rate for the new process. However, for Samsung, they have very limited customer right now. They have Samsung LSI, but their market share is declining. And previously, they have Qualcomm, helping Samsung to deliver the leading edge process. But the Qualcomm have been struggle for this kind of strategy because they tried the Samsung process for the last 2 generation flagship smartphone chip. However, they have the overheating issue and the impact the sales through for the Qualcomm product. In the end, the Qualcomm moved back to TSMC. So right now for Samsung, the problem is they don't have a very strong and a very big customer can help in them developing the leading edge process. So this is more like a chicken and egg problem. So since they don't have the big customer to drive the process, so the process development has been slowing down, and it's just keep deteriorating. The situation is just getting worse. So right now, I think that's why Samsung recently say they maybe push out the facility or delay the production schedule. I think that's the process development schedule for Samsung have some problem right now. And also, even in addition, Samsung itself, they have the semiconductor logic foundry business, but they also have memory. That's a very big portion. And right now in memory, they're also struggling for developing the HBM. So we know Hynix is leading in HBM, that's for sure. And there are a lot of people, a lot of news talking about Samsung fail or pass the qualification by NVIDIA or not. So even today, it's still not sure. Even today, NVIDIA cannot announce they really use a lot of Samsung HBM chips. So even for the memory business, which was the expertise for Samsung, they also struggling for this kind of high bandwidth memory development. So not just in one logic foundry, but also in memory. So the whole Samsung business looks like in some trouble right now. So I think that they may need some time to help to reverse the situation. Yeah.
So the struggle is real not just for Samsung, but it seems that struggle is also real for Intel. So Intel used to be the semiconductor powerhouse in the past, but seems that recently, maybe because of some wrong decisions, they're facing some difficulties, and there are rumors that Qualcomm would like to acquire Intel. Do you think that if this happens, will Intel, or like if by changing or restructuring the company, do you think that Intel is able to regain its former glory? Marco.
I mean, putting the Qualcomm speculation aside, let's look at Intel. Intel is a great company with a lot of engineering power. Just to put a little bit in perspective, Intel is spending on R&D what NVIDIA and AMD is spending combined.
Wow.
Yeah? So, and you know, NVIDIA, AMD, they are part of the AMD, of the AI frenzy. And so Intel would normally also be, but because in the past they made some wrong decisions and they catch up on you. Yeah? So, and I think Pat Gelsinger, the new CEO, when he came on board, he's an engineering mindset, but he needs time. He needs time. In semiconductor, when you decide for a wrong turn, you cannot easily go back. So you need to have time to build this up again, that you come on the right track. And so for Intel being so dominant on the x86 computer architecture, they enjoyed almost like a monopoly for decades, where they made a lot of money. And so for them to change this, they had a lot of CEOs who were very much driven by finance, not really by engineering. And so they tailored some decisions focusing more on the stock performance, on the stock market. Now, to catch up with TSMC, which is kind of master of execution on technology, the Intel and TSMC are very strong connected with each other, right? I think TSMC probably would not be there today without Intel, but for Intel, it's very, very hard to catch up right now with TSMC. One thing what Intel is trying to do right now is they want to adopt high NA EUV technology as the first company. So they bought the first machines from ASML, which is kind of the only company in the world which makes these machines. They are double the price than EUV machines. EUV cost $150 million, these new machines $300 million. And when you are the first one, you need to master it by yourself, right? So you need to do more investment there, but you have the chance, if you master it, that you can be in the front of competition. So still they have the challenge, they need to find products to utilize this, Apple doesn't need to worry because they are standing in line, and want to go to the newest technology. They have a lot of customers. Intel foundry businesses, what they want to expand, they are kind of new. And the challenge is the attitude from Intel, coming from a real men have fabs attitude to be a design company who manufacture by themselves, to open up as a customer service oriented company like TSMC is very challenging. And I think that's where they struggle right now. But I would never give up on Intel because these people, they are very, very smart, very bright people. They have helped for decades to thrive with Intel. But it's a very challenging task for the CEO and all the team to manage through there, especially when you have also the financial market pressure because they want to see result. They are not really known to be patient. Right, Jonah?
Yes.
In this ever-changing world, right? So you have to seize the opportunity. And I like what you said, Intel has to make this huge investment to see whether that will pay off in the long run.
Right.
So we have talked about Samsung, we have talked about Intel. Now let's take a look at China. China's chip industry is facing very severe pressure from the U.S. export restrictions, but it continues to grow. The New York Times recently reported that various export controls imposed by the U.S. on Chinese chip technology have, on the other hand, forced Chinese chip manufacturers to advance significantly. SMIC, one of China's leading chip manufacturers, is developing a new AI chip, the Ascend 910C for Huawei. And additionally, Nikkei's Chinese version website reported that a Japanese semiconductor research company, after dissecting a Huawei smartphone, stated that China's chip technology is only 3 years behind TSMC. So here comes my question. Do you think that there's only a 3-year gap between China's chip or semiconductor technology from Taiwan's TSMC, Jonah?
I think definitely more than 3 years. I think, put this way, I think China is focused on developing their own semiconductor supply chain, and they focus more on what they can do. So not just highlighting they can catch up very quickly. So basically, from what I know, is they try to make sure they can have a 28 nanometer process, domestic process, all made in China, including the equipment, material, and the foundry process, everything made in China. So focus on the legacy process above 28 nanometer. And for this kind of project, I think they're already 80% done. Basically, except the DUV, which provide ASML and also the photoresist. And except these two products, all the other equipment or material, almost they already have the China local supply chain to do that. So first thing for them is they try to make sure they have the local supply chain, can do the mature process to make sure even whatever US government put pressure on them, that will not impact their local supply chain. So that's the first step. And of course, the second step is trying to catch up with TSMC, but that's a long way to go. The first barrier is they don't have EUV. And if you go beyond 7 nanometer, you need EUV for sure. Even nowadays, they say they're using double patterning or even core patterning to using the DUV to produce the similar performance like EUV, but it takes a lot of time and also not very efficient. Also, the yield rate may be very, very low. So definitely, if they want to catch up, it will take a much longer time for them, unless they have their domestic EUV equipment. Maybe we can say they finally can catch up in the leading edge process, but I think that will take at least definitely not 3 years. It will take much longer years for them to have this kind of a leading edge supply chain. So for mature process, I will say, okay, maybe in the next 2-3 years, they will have the whole supply chain by themselves. But for leading edge, definitely that's still a long way to go.
Marco, what's your observation?
No, I fully agree with Jonah, what he mentioned. The focus for China at the moment is to build up their own semiconductor equipment system so that they can utilize this. You have to understand that even today, companies like ASML, almost 50% of their revenue is in China. So if China is able to build up their own equipment, these companies, Lam Research, Applied Materials, you all can name them, they will have severe challenges. Because the thriving market where a lot of investments are is in the APAC region. And so also companies like IC design houses also utilize foundries in China, also Taiwanese companies, because you have also a huge market with the handset market where they are producing the chips there. So today we probably see on major process node a 30% price difference from SMIC to Western foundry companies. And I think this gap might get even bigger. So international companies need to make judgments where they are producing the products at the end. So for China, it's only they want to be protected, that if there is any new sanctions, and the sanctions come very quick. And you know, Jonah, in our industry, it's like you plan long ahead. It's already very difficult. CapEx, demand, you know, how to manage this. And now sanctions come in there and companies made a decision. They cannot change it again because you spent already there. That's really the big challenge. And I think I also fully agree, we are not 3 years ahead. So I hear, or 3 years different. So I hear 3 years, I hear 10 years. And we need to look more granular on where. And yes, China has no access to EUV technology, but many ways lead to Rome. They might find other ways to reach that goal, but then it's the question, how can you scale it? How quickly you can make a big volume.
Also the yield rate.
Yes,
like what you
yield
said.
rate and also scaling. This is a huge challenge for any kind of manufacturer in this industry. And there TSMC is top level.
So let's just hope that TSMC will continue to maintain its leading edge, and hopefully TSMC and our semiconductor industry will continue to be the silicon shield for Taiwan's safety. So that's all the time we have for now. Thank you very much for your insights. If you like our show, please search for us on YouTube, give us a thumbs up, and hit subscribe to our channel. Thank you for watching our show today. Stay safe and see you next time.
I want competition with China, not conflict.
The entire world has great interest in keeping Taiwan's chip industry functional.
So the silicon shield that supposedly has been protecting Taiwan.
How many years the TSMC can still maintain its competitive edge?
What do you see as the next big shift in the semiconductor industry?
Taiwan's take on global headlines. All that matters, Taiwan Plus.